Okay, now it should be go. Okay. So we'll try this, see how it works. Okay, warm up. Okay, Michael Phelps is training for the Olympics. He finds that every time he swims the 200-meter butterfly, his personal best time in the race drops. Below is a graph of his personal best time. Is the scatter plot above a function? Yes. Yes, it is. Why is it a function? Okay, because it passes the vertical line test. B, should you connect the dots? Again, this is a big question in this unit. Why not? Okay, because there's no data in between the points. He can't swim, or he's not going to swim 1.5 races. Okay, he's not going to have a time for 1.5 races. He's going to have a time for 1 race, 2 races, 3 races. So there's no data in between the points. What is the domain and range of the relation above? What's the domain? And now, if you put that on a quiz or test, that's wrong. Okay. The domain is specific numbers. Okay, so the domain would be 1, or actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that's your domain. Okay, it's not races swum. Okay, so make sure you put the numbers, not just the words. Okay. And make sure you include 0. Okay. Now range. Okay. Now range is a little more difficult to tell because we can't really tell where some of these are. Okay. So we can't just say 50, 55, 60. Okay. We actually need all the numbers in between there. So for the first one in the range, it would be 60. The second number in the range, that was about like, I don't know. You could, if you put 69, I take, or 59, I take that, or 59.5. You know, you just get it somewhere close. Okay. Then the third number, that looks like about 57. And then you go all the way down till you get to right here to the last point at 15, and that would be 51, 52-ish. Again, this is a little hard to tell on this graph. A couple of the graphs we're going to look at today, it's a little hard to tell. But on the quiz tomorrow, it shouldn't be as hard to tell. Okay, any questions about that? Okay. There's your homework answers. Take a second, look over it. Okay, any questions? Any questions about this? Notice where the age is. The age is on the x-axis. The height is on the y-axis. If you have that backwards, then that's wrong. Yes, ma'am? No, no. No socks. Yes, sir? Yeah, that's fine. There's several different ways you could describe this, but it's constantly going up. Your height's going to increase from 0 to 13 here. Okay, any questions about that? Any other questions? Yes, sir? Mm. Yeah, it should be 2. 4D should be 2. Sorry about that. Yes? Well, you just look to see, at 18 months, he was at 34 inches, and at 6 months, he was at 26 inches, so you just subtract that. Okay, moving on. Okay, this is in your notes. This is just another example. Okay, this is another example. This is the notes that you have. It doesn't have the actual graph on here. We were going through this in first period today, and it reminded me why we don't have books for this class. Okay, the books are pretty pitiful that we would use. But we are going to go through this. This did come from one of the books that we would have used. So you have the data. You have the data above, or at the top of your paper. Okay, it's on the guided notes. Okay, so what you need to do is fill in the scatter plot. I want you to do 1 and 2. I want you to create the scatter plot, and I want you to answer the question for number 2. Okay, let's look at this. There's the graph. Okay, notice the age is on the x-axis and the weight is on the y-axis. Okay, if you have that backwards, it's wrong. Now, notice what they did in their graph, though. A lot of you didn't do this. A lot of you put 6 months, 12 months, 18 months, and then you put 2 years. 6 months is what part of a year? Half. 18 months is how long? Is a year and a half. So now, I probably wouldn't count off for that, okay, but you should know that that's just you should just put 1, 2, 3, 4, 5, 6, okay, because that's just, we're just using half a year. Now, the big question is, does it make sense to connect the points of the scatter plot? Why or why not? Okay, now, if we looked at this person at, say, 6.5 years old, would they be a certain weight, or would their weight just disappear for some reason? They'd be a certain weight. Think about it as yourself. Okay. Is anybody's birthday today? No? So that means you're in between birthdays, right? And if you step on some scales right now, you're a certain weight, right? You weigh a certain amount. Just like this person in this graph. They weigh a certain amount in between their birthdays. Okay? So since they weigh a certain amount, that means what? What does that mean mathematically and graphically? So what? There's data in between the points, and we connect them because of that. So yes, we connect them because there's data in between the points. Any questions on that? Okay. Describe the shape of the excuse me. Describe the shape of the graph, which is not up here, but the graph does what? It increases. Number 4. During what 1-year period does the average weight of boys increase the most? Just 1-year period. Okay, so there's actually 2 of them. 12 and 13, and then what was the other one that went up by the same amount? 10 to 11? Okay. There's 2 of them that go up by 10 pounds. Okay, so there's 2 that go up by 10, so it should be those. How would you use the table to answer this question? Okay, you would look at the table and subtract all the amounts, or from year to year, and figure out which one has the most. Now, how would you use the graph to answer this question? You would look for what on the graph? If we're looking for the most increase, then what are we going to look for? The what? The largest gap. Okay, the largest gap in the points. Any questions about that? Number 5, what are the domain and range of the relation? So the domain, what would be the domain? No, not 0. We don't have any data for 0 or 14. 6 months, or we could say 0.5. Okay, 0.5, 1, 1.5, 2, 3, 4, 5, 6, 7, 8, all the way up to 13. Now they just put that in words. The range is all the weights between 16 and 99 pounds. I'm looking for 16, 23, 24, and be honest with you, if you just write 16, 23, 44, ... and then put the last one there, 99, I'll take that too, as long as I know what the range is. Is the relation a function? Yes. Why? Passes the vertical line test. Or only the relation of the function because each age has one and only one average weight. Use the graph to answer each question. What is the average weight of a 6-year, 6-month-old boy? So 6.5 years. What's the average weight? What would that be? Where are we going to find 6.5 years? In between which 2 years? 6 and 7. So that means it's between 55 and 49. Now how am I going to find the average of those two numbers? Add them up and divide by 2. So 55 plus 49 divided by 2 equals 52. Okay, 52 pounds. What is the average weight of a 14-year-old boy? No, that's not on there. What do you think? This requires you to think a little bit harder because it's not in front of you. Any ideas? Okay, what do they normally go up by? What's it been going up by? It's going up by 10. So we got to figure it's going to go up by another 10. Now, I don't know exactly what they put in here. They put 104 or 105. The last 2 years it's gone up, 10. It went up by 4 the year before that. So that one's kind of iffy question just because it's not as set in stone as in your homework last night, where it was going up by the same amount every year. Okay. So that one's a little iffy. That's part of the reason we don't like the book. Hopefully I won't put that on a test. And if I did, it'd be multiple choice. At what age does a boy have an average weight of 65 pounds? Okay, so 65 pounds is in between which two numbers on the weight? well, 8 and 9, so 69 and 61. So the average age would be between 8 and 9. Let's say 8.5-year-old. The relation only includes ages up to 13 years. Using the graph, what would you predict as the increase in average weight for boys from the ages of 13 years to 21 years? What do you think would happen? Think it increased by what? By 3 or 4? Okay. Okay, so what about any other thoughts on it? I mean, there's a variety of different answers we could use here. There's not one set answer here. What do y'all think? This requires you to use your brain a little bit. So, no opinions. No thoughts whatsoever. Okay. So you mean take each one of those and multiply it by 3? Or take 55 and multiply it by 3? You're not answering. You're just shaking your head yes. Which one? Multiply the 7th year by 3, okay. What do you think? So she's saying get the average of all the weight increases, and that would be the average amount of weight that's being increased. And then we got to calculate that and get, I don't know what it does here. They just said 7 pounds. I think that's probably what they did, but I'm not too worried about that question. Okay, I'm just trying to get you to think about what you could do to predict the age. I had somebody in first period ask the question of, they asked, well, when we get down to this last one, I'll tell you what they said. But they said, using this predicted average increase, what would be the average weight for boys at 21 years? So if you use 7 pounds, if they go up by 7 pounds every year, when they hit 21, they're going to be at 155 pounds. I was well over 155 pounds at 21. Okay. Yeah, see. So the last question is, does this prediction make sense? Why or why not? Does it make sense for a 21-year-old male to be 155 pounds? No, most are not going to be that much. Most are going to be a lot more. Okay. But I had a girl in first period ask about that, say, well, if it doesn't make sense, then why do we just do those questions, you know? Okay, well, it's just a prediction. It's like the weatherman predicting the weather. Okay, he looks at all the past information, and then he makes a prediction about what's going to happen. And that's what they're trying to get you to do here. Okay, any questions about that? Again, this was from the book, so it's a little iffy. What we're going to do now is you're going to do that last page for homework, but I want to go ahead and go over the review. Alright, let's look at the review. Match the appropriate term with its definition. Domain. Which one of these definitions go with domain? All what? All possible inputs, which is choice what? E. Number 2, function. What do you think that would be? I heard B and I heard D. D. Every input has exactly one output. That's the definition of a function. Range. A. All possible output values. 4. A relation. B. A pairing of two values, input and output. And vertical line test is C. Any questions about those? That's going to be the first part of your quiz tomorrow. Number 6. Complete the statements with the following terms: X value, Y value, independent variable, and dependent variable. In a relation, the input value can also be called the, what else can the input be called? X value. Or the independent. Remember, IN is an independent and an input. And then a relation, or in a relation, the output value can also be called the Y value or the dependent variable. You need to know that for tomorrow. Okay, given the relation below, state the domain and the range and tell whether or not the relation is a function. So for number 7, we have points. Okay, the domain would be what? 1, 3, 5, 6. The range would be 2, 4, 7. And you can put another 7 there if you want to, but you don't have to. You could just put 2, 4, 7. That's fine. Is number 7 a function? Yes. Why is it a function? X values do not repeat. It does not matter about the Y values. All we care about is the X. Number 8. Okay, the domain is what? 3, 4, 4, and 6. The range? 2, 8, 9, 7. Is that a function? No, because what repeats? The X values, or 4 repeats. Okay. Number 9. The domain is what? The range is -6, 1, 4. Is that a function? Yes. Okay, there's not, you only have one arrow coming from each X value, so it is a function. Number 10, the domain is what? 0, 1, and 2. The range is -5, -3, -2, -1. Is that a function? No, because 1 has 2 arrows coming from it. Any questions about that? Okay. What was that? 11 and 12, they don't have a graph. There's just 2 coordinate planes, so we'll just skip those. Okay. For which of the following should you connect the dots? Okay, now look at the data presented in both graphs, A and B. In A talks about time and distance. Okay, we're talking about distance here. In B, we're talking about number of iPods and the total cost of each iPod. Okay, so which one do you think would it make sense to connect the dots for, A or B? Okay, let's think about it. After, say, 25 seconds, have I gone a certain distance? Or, yeah, 25 seconds. Yeah, I've gone a certain distance, right? After, let's say, 42.5 seconds, have I gone a certain distance? Yes. So there's data in between the points, so we need to connect those. So A would be the answer. Now let's look at why B is not an answer. Can you have 1.5 iPods? No. Unless there was a bad accident. No. You cannot have half an iPod. Okay? You either have the whole one or you don't have one. So there's no data in between those points. Okay? Any questions on that? I wasn't a big fan of 14 and 15 because those graphs are so hard to read. Okay, you can't really tell where the X and Y values are for those two graphs, so I just kind of took those off the slide. 16, construct a scatter plot of the data below and use the scatter plot to answer the questions below. Only connect the dots if you should do so. Okay, so we have our scatter plot here. This is going to be my y-axis. This is my x-axis. Okay, what should go on the x-axis? Depth or temperature? Depth. So that means temperature goes here. Now this is a very small scatter plot that I have. Yours is kind of small too, so you might want to adjust your values down here. That's going to be 0 no matter what. And then I'm going to, this is kind of hard to tell. We'll go 300, 500, 1,000, 2,000, just somewhere in there. Yours, you should be able to do a little better than that. Okay, I'm up here on the smart board, and you know it's hard to write on this thing. I'm usually orienting it all the time. Temperature, we'll just say 5, 10, 15, 20, 25. At zero, what's the temperature? 22. So the point should be right there on the y-axis. Okay, at 300 meters, what's the temperature? 20. We'll use that line. 500 meters, what's the temperature? 13. So we'll use this one somewhere. We'll say that's 13. Again, yours needs to be a little more detailed than this. It's just hard to do it up here. 1,000. What should it be on? 7. So let's say right about there. And 2,000. 6. Okay, so what do we notice about our graph when we get down here to the bottom? It's kind of doing what? It's still decreasing a little bit, but it's kind of starting to level off a little bit. Okay, once we get down that far, okay, it's going to start to level off. So use your scatter plot to predict the temperature at 2,500 meters. So what do you think it's going to be 500 meters further than what we have on our scatter plot? Either, again, this is kind of close. EOCT, multiple choice. I'm sure they wouldn't give you 6 and 5 as your answers. Okay, but it could stay about the same. We could say 6, or we could say 5. It's a prediction. There's no wrong or right answer for that one. Now, if it was always going down by the same amount every single time, then there would be a wrong or right answer for that. Yes, sir? The domain would be 0, 3, 5, 1,000, 2,000. Well, here you're still going to say the range is 22, 20, 13, 7, 6. Okay. Now, we're not done with it yet. Hold on. We got one more thing we got to take care of. The all-important question. Only connect the dots if you should do so. What do y'all think? Should we connect the dots on this? Why? Because there's data in between. If I go down 200 meters, the water's still going to be a certain temperature, isn't it? Yeah. Okay, any questions about that? Your homework. Just to give you more practice, your homework is on the back of the notes you picked up over there. Okay, you need to do that. That's going to give you some more practice. And